Hello and welcome again to part 2 of factoring quadratics. In this lesson, we will talk about perfect squares so that we can factor by a difference of squares, and we'll look at factoring perfect square trinomials. Also in this video, we will talk about factoring by grouping. We mentioned this in part 1 of our video when we talked about splitting the middle term approach, but we will go over it here a little out of the context of quadratics. So let's go over perfect squares first. So just so that we are on the same page, if we're talking about perfect squares, a perfect square is a number multiplied by itself. So if we start out with 1, 1 squared is 1, which means that 1 is a perfect square. 2 squared is 4, so 4 is a perfect square. 3 squared is 9, 9 is a perfect square. So is 16, 25, 36, 49, 64, 81, and 100. Obviously, they keep going past here, but I can't keep going and listing them all out, so I just listed out the first 10. Difference of squares. What you are looking for this approach is that you're looking at a binomial that is being subtracted. So two terms that are being subtracted, of which both of those terms have to be perfect squares. So we have our little rule here. We're going to take the square root of each one of our two terms, put them in the first and the last spots accordingly, and then our signs are going to be different. One will be a plus and one will be a minus. It doesn't matter which one's which, but they must be different. If we take a look at our first example here, x squared minus 36, we see that x squared is a perfect square. We see 36 is a perfect squared and there's subtraction in the middle. So we have all of our criteria met. We're looking at a binomial that is being subtracted, and both of those terms are perfect squares. So just like our method says up above, I'm going to draw out two parentheses. I'm going to take the square root of my first term. So the square root of x squared is x, and that goes in the first spots. Square root of 36 is 6. That goes in the second spot. And I'm going to have opposite signs. So one is a plus and one is a minus. And that's it. Super simple. 4x squared minus 81. This is also an example of a difference of squares, because the square root of 4x squared is 2x. I'll put that in the first spot. The square root of 81 is 9. And again, we need opposite signs. So just to show you it doesn't matter, I'll put a minus in the first one and a plus in the second one. It does not make a difference. We just have to have opposite signs so that our outer and inner terms, when we FOIL, cancel each other out. Our last example here, 100x squared. Well, the square root of that is 10x. So that goes in my first spot. Square root of 1 is 1. And again, opposite signs. So one's a plus and one is a minus. And we're done. That's a factoring by a difference of squares. So you just need to recognize your perfect squares and you should be good to go. Recognizing a perfect square trinomial, though, is just a little bit more complicated. Here you're looking for a trinomial, 3 terms. Both the a and the c terms have to be perfect squares, so that's easy enough to recognize. But trying to get that b term is where it might take a minute to recognize it. You're looking for the b term to be twice the value of the square root of a times the square root of c. So if we take a look at the first example, r squared plus 6r plus 9, if we use the factoring technique that we see here, the plus or minus is in place because either both signs are positive or both signs are negative. You're not going to have opposite signs here. So we're looking at both signs being positive, and in this case, they're both going to be a plus. So if we're going to draw out our parentheses, square root of r squared is r. Put that in the first spot. Our c term here is 9. Square root of 9 is 3. So I'll put that in the second spot. And because we want to get to a positive 6 here, that means they're both going to be pluses. So this is called a perfect square trinomial because you can also rewrite this as r plus 3 quantity squared. You might recall this type of appearance from when we were talking about factoring quadratics or graphing quadratics using our vertex form. This would be an example if this was an equation of a quadratic that has a vertex at -3, 0, because this graph got shifted over to the left 3 units. So same kind of concept. If we look to the second example, So let's draw out the parentheses again. The square root of 4x squared is 2x. The square root of 9 is 3. And again, we're looking for the same sign and both of them to be pluses. So plus and a plus. And again, if you want to write that as quantity 2x plus 3 squared, that works. For our last one, square root of x squared is x. Square root of 16 is 4. And here we're again looking for the same sign, and they're both going to be a minus. Okay. That's it. That's factoring a perfect square trinomial. So the most challenging part there is being able to recognize that you could factor using that approach. Again, if you think you can, but you're not positive, you can go ahead and try to factor it and then use your foiling skills to be able to prove that it does equal the original expression, and that's how you know that you did it correctly, or you can use that technique. Our last technique that we are going to go over is factoring by grouping. This is used when you have 4 terms. So we're going to group our first 2 terms together and our last 2 terms together. We're going to factor out the GCF from each group. The GCF in the first group is 3x. When we do, we're left with a 2x plus 1. When we factor the GCF out of the second set, GCF is 2. So again, that's going to leave us with the 2x plus 1. Just like in the first video, when we were factoring by splitting the middle term using a piece of this approach here, we know that the parentheses have to be the same. If they're not the same, either you cannot factor it by grouping or you made a boo-boo. So first, double check to make sure you didn't make a boo-boo. And then you could say after that, if you didn't make a mistake and you're confident on that, then it's just not factorable by grouping. So you have to try to find something else. So if they are the same, then that turns into be the GCF. So that's our first factor. And then what you're left with, so we're left with a 3x and a positive 2, right? So this 3x and this is a positive 2, and that'll go in our second set. And we're done. All right, let's do it again. We got a couple more practice examples. Again, if you want to go ahead and hit pause at any point and try them yourselves, that's usually a good idea. So grouping my first 2, grouping my last 2. GCF, x, leaving me with 2x plus 5. GCF of the second set is 3, leaving me with, again, 2x, just forgot about that, plus 5. So final answer, 2x plus 5 and x plus 3. No, the order doesn't make a difference. You can put the x plus 3 first. That's totally fine. You'll still get the same answer. Let me, circle that. Let's move on to the next one. So let's take grouping the first 2, grouping the last 2. I'll move it down a little bit. GCF of the first set looks like 3x. We'll be left with 4x plus 1. GCF of the second set looks like that's going to be a negative 2. So in that case, we're going to be left with, again, 4x plus 1. So in that case there, final answer, 4x plus 1 is one factor, and 3x minus 2 would be another factor. Okay, if we take a look at our last set, let's see if I can type it in, see if it will fit. For grouping our first 2 terms together. So GCF here is going to be 2x. When we divide, we're going to be left with 8x minus 1. GCF of the second set, it looks like that's going to be, I'm going to take out a negative 3 here, because note, when I go to divide, I'm going to have the 8x and a minus 1. Remember, we had said before that if we're going to choose to use this approach, then our parentheses have to be the same. So some people might want to just take out a positive 3 here, but then you'd recognize that your signs in the parentheses are opposite of what you need them to be, and they would have to be the same to use this method. So final answer is that same parentheses, the 8x minus 1, multiplied by the quantity, 2x minus 3. Well, that's what is left over. Right? So that is our factoring by grouping. Thank you so much for watching the video. If you got any questions, you know how to reach me. Thank you.